over the equation of a line, and the form that we look at is called slope Y-intercept form. And what that is when we look at y is equal to mx plus b, that is called the slope Y-intercept form. There's actually quite a few different ways to write a linear equation, but we're going to focus on this one. Okay. First thing we're going to do is we're going to actually get this equation from looking at a line. And there are two important pieces of information we need to find. We need to find the slope and the y-intercept. How can I find the y-intercept from looking at the line?
0, 0,
The y-intercept is when our x is technically equal to 0, right? So when x is 0, chapter 6. What coordinate are we at right now? 3. So this coordinate for our y-intercept, and I guess I'll do it in green here, is at 0 and 3. So our b is positive 3. Just built that part of the equation. The next thing we need to figure out is our slope. Now our slope is a little harder. Remember our slope, which is called m, is also equal to y2 subtract y1 over x2 subtract x1. Okay. So we're going to find some coordinates along here. One of the coordinates we have are 0 and 3. We can use that one if we like. Another coordinate is here. Okay. That's at 6 and 8. We can name whatever number or whatever coordinate we like the first one and whichever like the second one. So let's call the green one our number 1. So this will be our x1 and our y1. So this is coordinate 1. And we'll call this our coordinate 2. So this is our x2 and our y2. I'll write those coordinates here so it's easier to look at. Our x2, y2. And 0 is our x1 and y1. We now take these values and we plug them into the equation above to figure out our slope. Okay? So, m is equal to y2, which is in purple here, is 8. Subtract y1, which is in green, 3. Divided by x2, which is in purple, 6. Subtracted by x1, which is our green, is 0. So if we go to equate this, what is 8 subtract 3? And 6 subtract 0? 6. What's the slope of this equation? 5 over 6, which is known also as the rise over the run. Remember, we've been talking about that for a while. So I'm going to plug that value into our equation. Our m is 5 over 6, and I keep my y and my x. This is the equation of the line that we've just graphed. So we've just built the equation by finding the slope and the y-intercept. And we can kind of test it. Remember, it said that our rise is 5, so we go up 5 units. From 3, we would go up to 8. Better do that in another color here. So this is a rise of 5 and a run of 6, so from 0 to 6. And that's exactly what we found with our rise and our run. We went up, positive 5, and went to the right, positive 6 units. So that's the slope of this line. From looking at the line, we've just built the equation. Now let's say they've given us something different. We'll call this example 2. Let's say they've told us that the m is negative 2 over 3, and our b is negative 1. Okay? They've only given us the m and the b. I need to create the equation of this line. The first thing I want to do is plot my b coordinate. B is negative 1. Where would that be on this graph? Yeah, it'd be below 0. It's when x is 0 and y is negative 1. So this is our b coordinate here, at 0 and negative 1. Okay. They've also told us our m is a rise of negative 2 and a run of positive 3. So that means I would go down 2 units from here, so 1, 2, and over 3, 1, 2, 3. And then I can continue that pattern. I go down 1, 2, and I'll show you what I'm doing with this highlighted thing. One down 1, 2, over 1, 2, 3. Go down 1, 2, over 1, 2, 3. Here's our new point. And if you notice, we're going to be able to draw a straight line through all of these. Now this is what's tricky with m. Sometimes it'll be written like this. Is this a different slope? No, it's not. Let's continue that pattern. This says we go positive 2 on the rise and negative 3 on the run. So, starting at this coordinate, if I go up 2, 1, 2, and then negative 3, 1, 2, 3, here's my coordinate. Is that still going to fall on our line?
Yeah.
Yeah. So it doesn't matter whether negative is on the top or the bottom of their equation. We're still on the exact same line when we've been given m and b. So both of these are actually the exact same. There is no difference. Because this is a negative divided by a positive or a positive divided by negative. Both of them give us negative values, which means we have a negative slope. And this is a negative slope, which we looked at in decimals, right? Here's a positive slope. And finally, the last thing I want us to do, call this example 3. Let's say we're given y is equal to, I'm going to call this 1 over 8 x minus 9. Here's our equation. I want to be able to graph that. So in order to graph that, we want to pull out our m and our b, which we just looked at in our last equation. So remember, we have y equals, and it might be best to write our original equation underneath it so we can decide what our m and our b is. What is our b in this equation? Yeah, negative 9. So in other words, that coordinate is at 0 and negative 9. And what is our slope?
1.8.
Not 1.8, but 1 over 8. And it's always easiest to write this in a fraction because the fraction essentially lets us know what the rise and the run is. If I'm given 0.25 as a value here, it can be really hard to figure out how much to go up and over by. Okay? So usually our fractions are easiest to look at. So we go up 1 and over 8. So let's plot our point. We'll do this one in purple at negative 9. Our slope was a rise of 1. Right? So we go up 1 unit. And then a run of 8. So we go over 1, 2, 3, 4, 5, 6, 7, 8. So here's our next point. Okay? Now, what's neat about this is our slope was technically, and I'll write it over here, m was equal to 1 over 8. What about this? Is that the same slope?
Yeah.
Why?
Because of negative.
Yeah, a negative divided by a negative is positive. So both of these end up actually being the same. So let's go down 1 into the left 8 and see if we end up on the exact same line. So if we go down 1 into the left, 1, 2, 3, 4, 5, 6, 7, 8, are we on the exact same line we had started with? Yeah, this ends up being the exact same thing. So let's put our line in here. And we have our linear equation. So what we've done here is we've looked at a graph and built our equation by finding the y-intercept and the slope. With m and b, we've graphed our equation. And with our slope y-intercept form, we pulled out our m and our b and then graphed another equation.